Alright guys, we're going to pause our work on trig ratios for just a second and take a look at a skill that is more of just a general math skill. And it's this idea of rationalizing. So what I mean by rationalizing is if we have a fraction with a square root here, we don't want that square root to be in the bottom. Okay, so rationalizing the denominator means this. So we're keeping this fraction the same, but we're rewriting it. And I'll show you how that looks like, and then we'll talk about why we want to do this. So 6 over the square root of 63 is our example here. I'm going to multiply always by the bottom over itself. The bottom over itself. So root 63 over root 63. And what that does, remember multiplying fractions, you multiply straight across. You get 6 square root 63 on top. And on the bottom, root 63 times root 63, well, that's square root of 63 squared, right? Which those two things are opposites, so 63. Okay. So the reason I pick square root of 63 is because now I don't have the square root in the bottom, which is what we said we wanted, right? This number, this fraction that I multiply by, that's just like a fancy one, right? Fancy form of 1. Right, so anything over itself is 1. So by picking that number, I haven't changed the value of this at all. Okay, so the reason we want to do it, it's kind of like an old school thing. Like, this doesn't matter so much anymore. The reason this is the convention is that it makes it easier to estimate like what this would be as a decimal. Particularly with like the square root of 2, which is a common result that you tend to kind of memorize, like about what square root of 2 is, and we're going to see square root of 2 a whole lot. Like having it on top of the fraction makes it easier to estimate what your result actually is. So that's why we do this. It's kind of not so useful anymore because we walk around with calculators in our pockets, right? But the reason you need to know how to do it now, to be frank, is that future math teachers of yours are going to expect you to be able to do this. And it's not that hard, right? Now, for this particular example, what we're going to do is we're going to simplify also square root of 63, because we want it in the very simplest form. You're not always going to have to do this, but in this case, I recognize that 63 is not prime, right? It has factors that are roots. So 63 is 3 times 3 times 7. Square root of 3 times 3 is just 3, so I'm going to rewrite this as 6. So that's my first 6 times 3. That's the pair that I'm taking out of the square root, times 7, which is what's left over. So let's see if I can make that clear. So 6, 6, and then my pair of 3's become my pair of 3 out here, and then I have that 7 left over. Okay. The bottom of the fraction is still 63. And then 6 times 3 is 18, right? So I'll say this is equal to 18 over square root of 7. And then 63 on the bottom. And that simplifies even more. So 18 and 63 are both multiples of 9. So I'm going to divide top and bottom by 9. And what do we get here? 2 root 7 over 7. That's my result. Okay. So this is what simplest form looks like. And you can kind of see if you knew what square root of 7 was, and you guys probably don't off the top of your head, right? But if you knew what square root of 7 was, this is easier to estimate than this if I wanted to guess what decimal that would be. Okay, we'll do one more. And then where we're going with this in the next set of problems is applying this to our trig ratios work. So we'll see what that looks like in a second. Okay, so here we have 1 over the square root of 20. Think in your head before I write this, I'm going to multiply by what over what here? You should have said root 20 over 20. So I picked root 20 because that's going to rationalize the denominator, right? Get rid of the square root. And then I picked root 20 on top because I want this to be equal to 1, so I'm not changing my fraction. So I get 1 times the square root of 20 is square root of 20 on top and on the bottom. Okay, easy enough. The square root of 20, we can simplify that some. So 2 times 2, perfect square, right? The square root of that is 2. And then we have 5 left over inside the root, and then 20 on the bottom still. So I kept my denominator the same, I only changed the top. And then 2 over 20. Well, obviously those are both divisible by 2, so I get 1 over 10. Still got a square root of 5. And then this is simplified. I don't have to write that 1 though, so I'm just going to leave 5 over 10, root 5 over 10. So that's it. That is rationalizing the denominator. So we'd say, like, my original denominator is irrational, and then my new denominator is rational. And again, we do this because this is how mathematicians like to write these things down. Okay, practice a couple of these. I don't think this is going to feel hard for you. If it does feel hard for you, you probably didn't watch the video very closely. So take a look at the examples in Delta Math, or come back to this video and you'll be okay.